Most people imagine hungry ancient humans doing one thing, picking up a spear and hunting a bigger animal. That sounds logical. It was also a terrible plan when the animals had already disappeared. The real survival strategy often began with foods nobody celebrated in cave paintings: roots, seeds, nuts, shellfish, small animals, and sometimes whatever could be found before the final meal was gone. Imagine you are standing beside a weak fire. Your group has eaten very little for 2 days. A hunt failed yesterday. Another failed this morning. The tracks are old. The herds may have moved. The fruit that was easy to collect last month is gone. There is no farm nearby, no warehouse, no emergency number. Nature, as usual, has no customer support. So what happens now? The obvious answer is to hunt harder, but that answer falls apart quickly. Large animals can provide a huge amount of food, but they are unpredictable. They move, fight back, and may disappear for weeks. A hungry hunter also becomes less effective. While every failed chase burns energy, the group cannot easily replace. Less food means less strength, which can lead to even less successful hunting. Archaeological evidence suggests that ancient diets were often much broader than the familiar image of one heroic hunter standing beside one giant animal. Researchers have found plant remains, fish bones, shellfish, small animals, and tools used for cutting, grinding, and digging. There was no single prehistoric diet. Different environments offered different choices, but one pattern matters. Humans did not survive by depending on one perfect food. They survived by switching. When preferred foods became scarce, people could turn to what researchers call fallback foods. They were not always easy to collect or process, but they could remain useful when better options disappeared. Gesher Benot Yaakov, in present-day Israel, gives us an important example. Sediments dating to roughly 780,000 years ago preserved evidence of a remarkably diverse plant environment. Researchers identified dozens of potentially edible plant species. The site also preserves evidence that Acheulean hominins processed hard foods and repeatedly used fire. This does not prove that every plant was eaten or identify with certainty which human species performed each activity, but it strongly challenges the idea that early humans depended only on large animals. In some environments, underground roots and tubers could have served as fallback foods. They could remain below the surface after leaves and fruit disappeared. But finding them required knowledge. You had to know where to dig, which plants were safe, and which roots needed cooking. A random root was not a meal plan. It could be a dangerous mistake. Seeds and hard nuts created a different problem. They were small, slow to gather, and often needed crushing or heating. But they could be more reliable than waiting for a large animal. Small animals, fish, shellfish, eggs, insects, and other local foods could also matter. We cannot reconstruct the complete menu of every ancient population. Soft foods decay. Wooden tools disappear. Many meals leave little or no trace. The evidence is incomplete. But incomplete does not mean empty. It means we must separate what archaeologists found from what researchers infer. Finding food was only half the problem. Much of it had to be transformed before it became useful. Fire could soften tough plant tissue and make some foods safer or easier to digest. Pounding and grinding could break hard seeds. Cracking long bones could provide access to fatty marrow. Where conditions and technology allowed, drying or smoking may have helped some foods last longer. At Ohalo 2, beside the Sea of Galilee, unusually well-preserved remains date to roughly 23,000 years ago. Waterlogged conditions preserved plant material that would normally disappear. Archaeologists found wild plant foods and a stone grinding implement with starch residues. The evidence shows that people were processing wild cereals thousands of years before farming became established. Food was not simply collected and swallowed. It was selected, prepared, and processed. Ancient meal preparation involved fewer containers and considerably more rocks. But the principle was familiar. Spend effort now so food becomes more useful later. Every method had a cost. Digging used energy. Grinding took time. Fire required fuel. Shellfish might be far from camp. The question was not only, can we eat this? It was also, is this worth the energy, time, and risk? Survival increasingly depended on making that calculation well. But even the smartest meal cannot fix an empty landscape. Sometimes, the answer was movement. Many hunter-gatherer groups moved with the seasons, following water, plants, animals, and known shelters. Archaeologists use settlement patterns, stone materials, and environmental evidence to reconstruct some of these movements. But we have to be careful. A camp may be abandoned for many reasons. Food shortage is one possible explanation, not an automatic conclusion. Still, mobility was powerful. If one valley failed, another might still have water. If a herd moved, people could follow. If a dry season returned each year, generations could remember where food remained longest. It lived in memories, stories, landmarks, and experienced people. A landscape that looked empty to a stranger might still contain food for someone who understood it. They might know where water remained, which roots needed cooking, and which tracks were fresh. That knowledge took years to learn. Losing an experienced person could mean losing part of the group's living map. Moving, however, was dangerous. Children had to be guided. Tools, hides, fuel, and food had weight. The next water source might be farther away than expected. Moving house in prehistory was not exactly a weekend project. And movement leads to a problem no single hunter could solve alone: uncertainty. One person might find food today while another found nothing. A week later, the result might reverse. Research involving recent hunter-gatherer societies shows that food sharing can reduce this risk. One theory proposes that sharing could work like a kind of social insurance. You help feed others when you can. They help feed you when luck changes. We cannot assume every ancient group behaved like a modern community. Modern hunter-gatherers are not living fossils. They have their own histories and environments. But ethnographic research can help scientists develop and test possible explanations. The basic problem is clear. Food arrived unevenly. Hunger arrived every day. Cooperation made that uneven world easier to survive. It also required memory. Who shared food? Who was sick? Who had children? Who knew where water could be found? Hunger may have strengthened not only food skills, but also social skills. Sharing helps solve today's shortage. Planning tries to solve tomorrow's. When conditions allowed, ancient people could preserve or store food. Evidence for storage becomes clearer in some later prehistoric settings. Possible storage installations have been identified at some Natufian sites. But a hole in the ground is not automatically a grain store. Its contents, construction, location, and context all matter. At Qesem Cave in Israel, researchers proposed a different kind of delayed consumption. Some animal limb bones may have been transported while parts of the skin remained attached, helping protect the marrow for later use. The interpretation is supported by marks on the bones and experimental work, but it should not be presented as a universal prehistoric storage system. Keeping bones for later marrow extraction is not the same as building a pit for seeds. Storage also creates new questions. Who controls the food? Who protects it? Who decides when it should be used? Archaeologists have not found enough evidence to prove one universal path from storage to inequality. Human societies were too varied for that simple story. The most important survival skill was probably not one food, one tool, or one storage method. It was flexibility. Ancient humans built what we might call a portfolio of survival. Large animals when hunting was good. Roots when food above ground disappeared. Fish and shellfish near water. Seeds during seasonal harvests. Small animals when larger prey became scarce. Movement when a region could no longer support the group. Sharing when one family had food and another did not. Storage when there was enough surplus and a way to protect it. No single strategy worked everywhere. That is the point. At many later Paleolithic and Mesolithic sites, evidence suggests a broader use of fish, birds, rabbits, tortoises, shellfish, and plant foods. Researchers sometimes discuss this pattern using the term broad-spectrum revolution, but it did not happen everywhere at the same time. Different communities expanded their diets in different places and for different reasons. Now the ancient problem enters your modern kitchen. Your refrigerator is storage. Your pantry is planning. Your emergency fund is a buffer. Sharing food or money spreads risk when one person has more and another has less. Modern life is not a simple copy of prehistory, but the underlying challenge is familiar. The future is uncertain. Resources do not always arrive evenly. People survive better when they can adapt, remember, cooperate, and prepare. So what did ancient humans do when food ran out? They changed the menu. They changed how food was processed. They changed where they lived. They shared risk. They preserved or stored what they could. And above all, they refused to depend on one answer. Hunger was a threat, but it was also a test of flexibility. Survival did not depend only on the strongest hunters. It also depended on noticing more, remembering where water could be found, understanding which plants were safe, learning quickly, cooperating, and improvising before the final meal was gone. That may be the most human survival skill of all. Next, let's investigate how early humans found water when rivers began to disappear.